Let us take one more question on meter bridge. The question reads like this: with a certain resistance in the left gap of a meter bridge, the balance point is obtained when a resistance of 10 ohm is taken out from the resistance box. On increasing the resistance from the resistance box by 12.5 centimeter, the balance point shifts by 20 centimeter. Find the unknown resistance. So let us try to understand what is given in the question and then let us proceed towards solving the question. So the question says certain resistance is in the unknown resistance is in the left gap. Therefore, resistance box is placed in the right gap. Now, with the unknown resistance X in the left gap and the known resistance 10 ohm in the right gap, we can write the balancing length is given as L. Let us say the balancing length is L from the 0 or the left end. Then using the concept of meter bridge and hence balanced Wheatstone's bridge, what we can say, X upon L will be equal to 10 upon 100 minus L. This is one equation we get, or we can write it this way also. X upon 10 is L upon 100 minus L. This way also we can write. Now let us go to the next statement. What it reads? It reads, when resistance from the resistance box is increased by 12.5 ohm, sorry, here it is centimeter, 12.5 ohm, the balance point shifts by 20 centimeter. So when you are increasing by 12.5, so now the resistance becomes 2210 plus 12.5. So therefore now we can say X upon balance length shifts by 20 centimeter. So we can say X by 22.5 is L minus 20 upon 100 minus L minus 20. This we can say. So let us simplify. This is from the second statement which is given. So therefore X upon 22.5 is equal to L minus 20 upon 120 minus L. This is what we get as the second equation. Now solving equation, so from equation 1 and equation 2, what we have is, so on solving these two equations, equation 1 and equation 2, see we are getting something like this. This precisely to say it, we are dividing the two equation. So 22.5 by 10 is equal to L upon 100 minus L into 120 minus L. So let us solve this equation. We get a quadratic in L, L square minus 120L plus 3600. So from this, by solving this, we get L is 60 centimeter. Hence X upon 10 is equal to 60 by 100 minus L that we have. From this we get X as 15 ohm. That is exactly how we can solve such equations if we know in which gap what resistance is placed and from which end the balancing length is measured. These are the very critical data, very crucial to understand the question and then use the equation properly.